Hello everybody! We are continuing on in section 5.7 talking about roots and zeros, and we're actually getting to the point now where we're going to solve and find the actual roots and zeros using some of the things we've been talking about in the section. You know, how we factored so we could do some basic solving, talk about how many roots an equation will have, whether they're going to be positive, negative, those kind of things. We're going to put that all together now to help us solve. And the first thing to note is what we've talked about before already. The complex conjugate theorem is just the fancy way, the official mathematical way of saying that our complex numbers, our ones with i's in them, come in pairs. That's all that's saying. So we're going to look at this example, and it takes up the whole page. Now when you solve, they won't take up quite this much page space, just because there's more words with it. And then we'll do some examples. I think I'll do the examples in additional examples in a separate video because this one will get long enough as it is. So let's start out. Example 3. You got to find all the zeros of x to the fourth minus 15x squared plus 38x minus 60. So first thing we want to do is talk about how many zeros is it going to have. It's going to have 4 zeros total. So that means when we make our positive, negative, imaginary total column, 4 is always what's going to be over in the total. So somehow we've got to get the right combination of roots that totals 4. Now we've got to figure out what kind of roots are we going to have. What type are those 4 roots going to be? Well, let's use Descartes' rule of signs to figure that out. So we're going to look at the positive version first. We'll go first term to second term. Sign change goes plus to minus. Second to third, minus to plus, and then plus to minus, third to fourth. So that means there are either going to be 3 or 1 positive real zeros. So I put that in my column over here, 3 or 1. Now we got to figure out how many negatives there are. Well, let's plug in the negative version. Well, whenever we plug a negative into something with an even power, the sign stays the same. So the only thing that really changed was that sign there. It went from plus 38x to minus 38x. So first to second term, sign change. Second to third and third to fourth, no sign change. So that means there's going to be 1 negative real zero. So we have 3 positive, 1 negative. That means no imaginary. 1 positive, 1 negative. That's 2, so 2 more imaginary. And that works because the imaginaries have to come in pairs to total 4. So that means now as we solve, we'll be able to eliminate some possibilities. Say, for example, we find a negative root. Once we find one, if we find 1 negative root, then we know after that everything is going to be either positive or imaginary. And at that, we're going to have at least 1 positive one. So that can help rule out a whole slew of possible answers. So now let's slide down, keeping this chart in mind. And for now, we're going to use a little bit of guess and check, but with some educated guessing. And we're going to use synthetic substitution to test some possible zeros. One place you can always start is try with 0. I don't in this particular example, but you can, and we will in other examples. And then numbers around 0. And sometimes it's helpful to make a chart to help keep things organized if you want. And I want to point out a note that I have at the bottom of the page. Because we'll be doing synthetic substitution multiple times, if a value is not a 0 or it's not a root for a polynomial, then it will not be a 0 or a root for a depressed polynomial and does not need to be tested again. So once you've ruled out a root, it's done. You don't have to try it again. So here, we try 2. We try 2, we do the synthetic division. 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4, negative 15 plus 4 is negative 11. Notice, remember they put in that's for the x cubed term. 2 times negative 11 is negative 22. 38 plus negative 22 is positive 16. 2 times 16 is 32. Negative 60 plus 32 is negative 28. It does not work. However, that means 2 doesn't work here and it doesn't work later. Because all we're really doing as we factor is breaking down this bigger polynomial. So if it doesn't work now, it's not going to work later. And the same is going to hold true as we go all the way along. So that's something to remember. Once you've ruled out a number, it doesn't work anymore. All right, 3. Let's try that one. Plug in 3. Bring down the 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 15 plus 9 is negative 6. 3 times negative 6 is negative 18. 38 plus negative 18 is 20. 3 times 20 is 60. Negative 60 plus 60 is 0. Yay! Remember, we want this remainder to be 0. When it's 0, that means this number has become a factor. And so we write it, remember, it's always x minus the number. And then we write our depressed polynomial and say, all right, now we get to keep factoring. So we're going to try down here. We've got one positive root. So now maybe let's shoot for a negative root because we know we're going to have at least one negative, or we have to have one negative in there. So let's go that direction. Try a couple of numbers. You try negative 2, you can see the whole process here does not work. And then you try negative 4. See the whole process and you see, doesn't work. But maybe we're getting closer. Then you try negative 5. Hey, look at that. 1 times negative 5 is negative 5. 3 plus negative 5 is negative 2. Negative 5 times negative 2 is 10. Negative 6 plus 10 is 4. Negative 5 times 4 is negative 20. 20 plus negative 20 is 0. Yay! So now we have still x minus 3 from up here, x plus 5, and x squared minus 2x plus 4 from our synthetic substitution. We've got a positive root, a negative root, because remember the signs are opposite, or you go back and look at how they were originally written here. Here is positive, here is negative. And then so that means if we go all the way back up to our chart, we had one positive, one negative, so that means our last thing has to be imaginary. That means then when we go back here to factor x squared minus 2x plus 4, we're not going to be able to factor that. So we're going to use the quadratic formula, which I have shown down here at the bottom just so you can see it all worked out. You quadratic formula just this piece, and you just ultimately end up with 1 plus or minus I times the square root of 3. That's 2 roots right there, so there's your 2 imaginary. So we can say a function has real zeros at 3, negative 5, and 1 plus or minus I square root of 3. And that's what you would write down as a final answer. But you can see we pieced together the different ways parts of things we've been using to help us solve to put that all together. Now in the next video, I will do some additional examples where we can see us working through this process a little bit more. Thank you.